which is if this flue got blocked for any reason.
Plumbers videos. So these are your videos that you send in. This one's from Kevin. So Kevin's back with one of his really detailed, technical, fault finding videos. If you've got any questions for Kevin, please put them in comments below. Thank you to Kevin, and yeah, let's go over to the video.
Good morning, YouTube. I'm back after a couple of months not making videos. As you probably well know, that I used to work for Ideal, and I've done quite a few videos on Logics, and you know, the Vogue is a crossover, as it's pretty much the same hydraulics in as the Logic. What you might not know is I spent a little amount of time at Worcester Bosch. In comparison to Ideal, it was very small amount of time, but nevertheless I did. I've done most things on the Logic and Vogue. I don't think I can really add much to that. So I've been thinking about what videos I can make to, you know, be useful and helpful. And I spoke to Alan a couple of months ago asking him did he have any Worcesters up and running in his man cave, and he didn't, unfortunately. So you know, that didn't go very far, but I do see that he's got a 4000 now, so maybe in the future I might be able to get over there and maybe make some on some live boilers. I don't have any Worcesters live that I can show you, but I was thinking about what I could do that might be useful, and I thought I'd start on the Greenstar Junior and the RI. I think it's probably Worcester's most sold or successful installed boiler out there at present. I think it is, I could be wrong. There's a lot of them still out there, and you know, I might do one on the fan, how to test the fan, because that's a point of contention with the fan speed resistor getting cold and ground into earth. But like I said, I probably need a live boiler for that. But in the meantime, I had a thought about talking about the safety circuit on the Greenstar Junior and RI. It's something that I don't think many people know, so I just thought this might be useful, and a lot of seasoned engineers might know this, but you know, some guys coming through to the repair side, or even apprentices might not know this. So I've done one of my diagrams again, as you can see, and the safety circuit is comprised of the no flow thermistor, which is pretty much like an overheat stat on top of the heat exchanger there, which is just a switch. We've got the flue stat, which is there on the bottom of the sump, which is like a overheat again for you know, the heat exchanger overheating. And then we've got the air pressure switch. This is what I'm going to talk about mainly, but what I'd like to describe at the moment, these are all wired in series. If you see, we've got from the circuit board, goes up to the no flow thermistor, out to the flue stat, up to the air pressure switch, and back to the boiler. This might not be completely 100% accurate. I've done my drawing the best I can. So this is the safety circuit pretty much, and it's designed to cut off the boiler in you know, to prevent it blowing or overheating or, you know, damaging the boiler. So obviously the first point we've got is this it's pretty much just a switch. So it's designed to act like a no flow thermistor. So we've got heat, very high heat at the top of the heat exchanger, which could suggest that water pressure is low. It doesn't have a low water pressure switch, so this is designed pretty much like what the ISAR did. It's like a no flow thermistor, so if we've got low water pressure, this should sense it. Doesn't always work, But anyway, it's just a switch and it'll break like about 100 degrees or 105 or something around there. So that's this one here. This one is the Flu-Stat, which is designed to sense overheat of, would suggest that the heat exchanger primary waters might be blocked or restricted. So, you know, the flue temperature roughly in these boilers, once it's transferred the heat to the primary water and heat exchanger, you should be getting roughly, and I say roughly, between 50 and 60 degrees flue temperature coming out here. You know, give or take around about 55. If you're increasing up to 70, 80 degrees flue temperature, this could suggest that the primary waterways are restricted and the heat exchanger isn't transferring the heat to the primary water, which is the primary water isn't picking up the heat. So this would sense the excess heat, cut out at the switch again, to stop overheat of the heat exchanger. But then if we come up here to this air pressure switch, this is what I really want to talk about, because on a standard efficiency boiler, an air pressure switch is made by sensing the fan pressure to determine whether the fan's running and let the boiler go to ignition. This air pressure switch is different. So on the Mark 1 Worcester Greenstar, if you look to the bottom left of the boiler, you'll see the little square condensate trap. And it's only a small volume condensate trap. And the idea of this air pressure switch is, if this flue got blocked for any reason, if the flue got blocked and the fan, you know, started pushing the air pressure through the flue, it could technically blow out the trap. It could blow out the trap. So what they did, they put this air pressure switch on and had this little tube to it here. So if the flue got blocked up here, the excess air pressure would push up this tube, push the switch across and cut the circuit, which would cut the boiler off. If you notice on the upgraded Greenstars, they had a bigger siphon underneath the boiler. So they upgraded the siphon, which would overcome the air pressure. So the little square trap was upgraded to a bigger siphon, which could overcome the air pressure from the fan if the flue got blocked. So they took this air pressure switch off. So most people would think an air pressure switch would work by, so if we've done a little other diagram here. So both types of boiler, a standard efficiency boiler and a Worcester Greenstar, the air pressure switch rests in the normally closed position. So that's where it would rest. On a junior and RI, once it goes to normally open, it means it's triggered, the excess air pressure has triggered the switch. So it cuts out in this position. On a standard efficiency boiler, when the fan is running and the air pressure switch detects the fan, the air pressure switch would go to normally open, which this is to sense the fan is running. This one is to sense there's an issue. So this one fails in this position, and this one acts as a detection of the fan running in this position. So it could catch some people out. So I wanted to talk about this really. This air pressure switch works in the opposite way to a standard efficiency boiler. So if you come to a junior or an RI and you're getting the boiler locking out and you're testing the air pressure switch, make sure you remember that it works. If it's in the normally open position, it means there's a problem, and it could be that the flue was blocked. It sent the excess air pressure up this switch, activated the switch and cut the boiler out. I just wanted to make that clear because this could catch people out. If you don't know how this works, you could think it works like a standard efficiency boiler and think there's nothing wrong with the air pressure switch, when in fact it works this way as a failsafe. So I hope I explained that properly. I'd like to be able to find a live boiler to show you. I mean, I can do quite a few things on the Junior or the HE or the CDI or whatever. There's quite a few little tips I could show you. The compact, the IERP, or even the new 2000, 4000, 8000. There's probably a few tips I could show you if I could probably get a live boiler, but maybe not in the future. I might see if I can get over to see Alan. But I thought this one might be just a good one to start off with anyway. It's quite simple, straightforward, but it could catch a couple of people out if you don't know that this actually works in the opposite way as a standard efficiency boiler. Okay, that's all I've got for now. I hope this helps somebody in the future. Bye-bye.
Thank you very much for that, Kevin. If you've got any videos that you want to send in, please send them in on WhatsApp. I'll add my details in here somewhere. Yeah, there. Yeah, please send them in. And thanks to Kevin. If you've got any questions, please put them in comments below. Yeah, thank you.